Okay, so that's the quick introduction to the homework number 1, which is about spatial interpolation. So your aim is basically to take points and create a DTM in raster, and that DTM should be created with 4 interpolation methods. We specify the 4 interpolation methods, so these are the ones that you've seen in lessons 4 and 5. So you need to implement nearest neighbor, inverse distance to a power with using a search circle, linear interpolation in thin, and also a basic kriging. We give you code to start, so you can just download the code, and I'm gonna go through the code and what you need to do to explain you a bit what you need to do. So when you unzip, you have a few files. So let's start with the input file that you get. So we give you an example. So the input file is samples.xyz. So this is a text file, so you can open it in your favorite text editor. And this is a CSV file, so comma separated value. Well, it's called comma separated value, but here we have separated the 3 fields. So XYZ, there's always a header, XYZ. And then each line is a point, which is X separated by a space, Y, and then Z value. So as you see, this data set here has 991 points minus 1 because of the header, so 990. These files are easily readable by QGIS. So for example, with QGIS 3, you can go and do add layer, delimited text, and then you can select that file. So if you open it, you can specify. So here you can see at the bottom, so I have spaces, my fields are X and Y. Then you can see what will be X, Y, and Z, and then you can see the file. So this is my data set here. Then we have the output file. So the output file is example output. So if you open it, it's also a text file. So if you open it, you can see that this is a very simple ASCII text format to store raster. So basically, it's very simple. What it does is that you have number of column, number of rows, the X at the lower left corner, the X at the lower, the Y at the lower left corner, the cell size, no data value, and then the list of values. If you saw, we had 3 rows, 3 columns, so then we have a 3 by 3 matrix basically, which give you the values. This is documented. I give a link in the assignment description. It's that file, the ASC file, is directly readable by QGIS3. So if you open that file, so that was a 3 by 3, you need to specify what is the coordinate reference system. So the ASC format doesn't have a coordinate reference system. So when you open one file, for example, that one, you need to go in and say my source is of that coordinate reference system. If you want to align it with your data points, for example, your sample. But if we forget the points here, and then we simply focus on that one. If you remember, or I can show it here. So we had 3 by 3, as you see, you have a 3 by 3. And then if you look at the coordinates here, the lower left was 0, so this is about 0. And then we had 10, so we should have 30, 0, that's what we have, 30, 30. And then if you look in the value tool, if you just check 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is how it works. Now the programming part. So the program is formed of 2 units, these 2. So basically there's GEO1015 homework 01. This is the main file, and then your code, which is called my code. So if you open both, in your favorite text editor, then it's written here, and I will highlight it. Do not modify this file. So you're not allowed to modify the main file. The main file, we will basically use always this main file, and we will only to mark, use your the code that you write and then import it the way it's imported now here. So if you modify something and it doesn't work, then you will lose mark. So yeah, so the main file, basically what it does is that there's only a main. It imports the code that you've written, the code that you write here. And what it does is that here you can see it loads the files of parameters. So this is the file param.json. So param.json is basically the details of what should be carried out. So that's a very simple JSON file that says what is the input file that I'm going to read. In our case, this is the sample XYZ, the one I give you to start with. And then you say I'm going to use a natural neighbor interpolation. I'm going to output to the file natural neighbor ASC and then cell size and some parameters. So if there's IDW, there's also other parameters. We only give you these parameters to start with, but you should of course play with these parameters and make sure that it works for different parameters, and you can test for different data set as well by changing the data set. So what happens when you run the main code is that it reads that file, creates a list of 3D points here, you can see, and then after that, depending on what is there, calls the interpolation methods that you need to write. These are in the file mycode underscore homework01.py. So here, be sure to write your name and the name of the colleague with whom you're doing that assignment. And then if you see, there's 4 methods. So there's basically NN interpolation, IDW interpolation, TN interpolation, and kriging. So your job is to complete each one of these functions, and each one of these functions will not return anything, as you notice here, but will only write a file to where it was supposed to write, so the parameters that are in the params.json. So you're allowed to, of course, add new functions to that unit, but you're not allowed to include other units. So I want all your code to be solely in that unit. And you're also not allowed to import anything from any library that you can find. So you're only allowed to import Python libraries from the standard library of Python, and you're only allowed to use SciPy and NumPy, these two. We give you example about here how you should be using that, but you're not allowed to import anything else. If in doubt, simply write to the forum to ask if it's possible to use this or that library. Yeah, so when it runs, you should see it runs only with Python 3, so no Python 2. So if you get errors, it's because you are using Python. If you get errors, maybe it's your code, but if you use Python 2, you will get errors. But if you want to run it, then it should just run. And then you see here, I have no code. It was very fast, but you should see this written when you run it. One small explanation about the file variogram.py that we give you. So instead of letting you code the whole kriging, we coded, let's say, half of it, and it's given in the file variogram.py. So if you open it, you see some code. And to run it, notice that you need to install Seaborn, which is a package. So you can simply do pip install Seaborn. The rest you should already have them, pip, matplotlib and numpy, for example. So this file basically helps you calculate the variogram, and then you try to fit the function for the experimental variogram. So the file will read by default the sample file that we give you. So if you run it, it calculates the variogram as you can see in the handout. And then you should see such a graph. So basically you see the 3 functions that are described in the graph, the exponential, the Gaussian, and the spherical function. And then you can see the result of the variogram. When you start it like this, it doesn't look very good, but that's because you need to find the exact well, you need to tweak the parameters that are used to calculate the variogram. So there's a few parameters that you can tweak. The first one is the number of bins. So for example, the number of bin now was 4 when you start, but if you put it at 8, you should get something different. And you can also play with the ceil and the range. So for example, if you put the ceil at 400, I don't know, and if you run it again, sorry, we don't have any automatic interactive way to define that, but as you see now, I change the value, and then I get a better variogram as it's explained in the handout. And then the function for which I have defined the ceil then will behave differently. So the idea is that you do trial and error to try to fit a variogram function. And when you're happy, then you can keep these values for the ceil, the range, also the nugget, and then you can use that for interpolating, and you can use these values that you put in your own code to interpolate with kriging. So for the kriging function, you only need to do the samples.xyz, and you hard code the values for the kriging that you have done with that file. We also give you more data set. So if you look in other sample, I give you, for example, a part in Tasmania. So this is a very simple DTM that I've also used somewhere else. It's here. I've shown. We use it throughout the course. That's a very simple one with water. So what we have done is we have basically sampled this DTM to create a set of samples that you can use as input. And then since you have the real or the ground truth, then you can see if your interpolation method is working nicely.